The topic is bitwise operators. If you have studied digital electronics, the basics of digital electronics, you may be knowing about these operators. And these operators perform operations on bits of data. As a computer is an electronic device, basically it works on bitwise operations only. So almost every programming language supports bitwise operations, and these operations are faster than compared to other operations. So if you can design your logic using bitwise operators, then your algorithms or your procedures will be faster. So, but it requires your own efforts for utilizing them. So here in this video, we will learn what those operations are and how they work. So let us see the operations. See, the bitwise operations available in Java are AND, OR, NOT, XOR, right shift, unsigned right shift, and left shift. In mathematics, AND looks like this is the symbol. Or in digital electronics also we use the same symbol. OR looks like this, NOT looks like this, XOR, that is exclusive OR, looks like this. And these are the symbols that are available in Java for performing these operations. These are the symbols of Java. Now they work based on some truth table. So I have taken truth tables here for AND, OR and XOR. These are the tables. So if you remember these tables, then it is easy for you to understand their working. Let us see how these are. See, I have taken two bits here, A and B, and when we have two bits, there are four possible combinations, that both bits are zeros, or one is 0, another is 1, or both are 1. So total four possibilities are there. Then how AND works, let us see. Both are 0, 0, A and B is 0, and 0, 1 also 0, 1, 0 is also 0, 1, 1 is 1. So it means AND will give result as 1 if both the bits are 1. Otherwise it is 0. Now let us come to OR. Both are 0. So 0 or 0 is 0. 0 or 1 is 1. 1 or 0 is 1. 1 or 1 is 1. So here it means if any one of the value is 1, then the result is 1. If both are 0, then only it is 0. If any one of the value is 1, then it is 1. There, if all the values are 1, then only it is 1 in AND. And in OR, if any one of the value is 1, then it is 1. Now let us see XOR, exclusive OR. Exclusive, that is, which means which stands out, which is separate. So let us see this. 0, 0 is a 0. 0, 1. See, one of them is 1, 0, and the other one is 1. So 1. And here first one is 1 and the second one is 0, then also it's 1. If both are 1, means 0. Both are 0 means they are same. It's a common. So 0. Both are 1 means they are same. It's common. So it is 0. Here we have 2. In this, if any one of the bit is 1, the other bit is 0, then it is 1. If you have multiple bits, then only one bit should be 1 and rest of them must be 0, then only it is 1. So this is a XOR table. So we have a truth table for these three. Then left shift, right shift is remaining. This works on shifting of bits. Now I will take some example and I will show you how these operators work. First let us look at AND operation. See, one thing, remember that all these bitwise operations can be performed on only integer type data. Only integer. If you are taking byte or short, also result will be integer. But you cannot perform on float and double at all, right? Don't think of performing them on float and double. So only integer type. So I have taken example of integers here. One integer x is having value 10 and y is having value 6, and also I have taken one variable z. Now I am showing the binary form of this 10. This is 1010. I have taken only 8 binary digits here so that we can easily understand and solve it, right? Because the leading all bits are zeros. Integer takes 4 bytes, so 32 bits. So all remaining 28 bits are all 0. So I am taking only 8 bits here, right? Then next value is 6. 6 is 110, and all these leading bits are zeros. Now see AND. What is AND? If I perform x and y, then ANDing is done on bits of this data, 0 and 0. 0, 0, what is the result? 0 and 0 is 0. Yes, 0. 1 and 1, and see 1 and 1 is 1. So look at the table for every operation. So 0 and 1 is 0, 1 and 0 is 0. These are all 0, 0 and 0 is 0. So these are all zeros. So result of this x and y is this in the binary form, and that will be stored in Z. So what is this? So if you look at these bits, all these bits are 0. So only this part is a number. So what is this? 2. Result is 2, binary form of 2. So if you perform ANDing on 10 on 6, then result is 2. So this is not arithmetic. It's not, we are not adding, we are not subtracting, we are performing ANDing. So you should be familiar with the bits of that data and how the operation is performed. So if you can figure out quickly, you can easily utilize these bitwise operation to develop your logic. Now next we will look at OR operation. So I will remove this and I will make this operation as OR. So let us perform OR on X and Y. X or Y. So look at this table. So here you can see that if any one bit is 1, then the answer is 1. Right? If both are 0, then only it is 0. Or 0, 0. 0 or 0, 0. 1 or 1, 1. 0 or 1 is 1. 1 or 0 is also 1. Then 0 or 0 is 0. This is also 0. This is also 0. This is also 0. So this is the result that you will get in Z. So what is the binary number? This portion is binary number. So how much this is? This is 1, 2, 4, 8. So this is 12 plus 2, 14. So answer is 14. Z will be having value 14. So bitwise ORing of 10 and 6 gives 14. Right? So this is OR operation. Now let us look at XOR operation on X XOR Y. For this operation, we look at this table. So in this table, if only one of the bit is on, then it is true, right? If both are off, if both are 1 or that is on, then it is false. You can see that 0, 1 is 1, 1, 0 is 1, but 1, 1 is 0, 0, 0 is also 0. So let us perform the operation. 0, 0, both are 0, so it is 0. Both are 1, so it is 0. 1 is 0, other one is 1, so it is 1. 1 is 1, other one is 0, so it is 1. Both are 0, so these are all 0. Then all these leading zeros are there. This is the binary number we got. So how much this is? This is 1, 2, 4, 8. So this is 12. So Z value will be 12. So performing XOR upon 10 and 6 gives 12. So this is XOR operation. Now let us look at left shift.